My name is Jayesh Dehankar, and I'm database researcher and developer in Zoho Corporation. Yeah. So I'll be talking about AI-generated fuzzy tester, which we created to find bugs in our custom streaming replication setup. Okay, so coming on the point, what is the problem? Why this fuzzy tester we actually introduced? So for our extension, the foreign data wrapper, we recently implemented custom streaming replication. And after implementation, the real challenge began. The challenge was like, how do we actually test the correctness of our replication under real workloads? So for that, traditional tests are like static tap tests, which PG provides via Perl scripts and all. We have fixed query sequences using like normal regression testing and all. We have some testing tools, the benchmarking tools, PG bench and all, where concurrently we can run fixed query sequences. We have some other tools like SQL Smith. We have SQL Lancer, but they don't do any DML, DDL events. They work on select only things. So what are the problems in this traditional test we found is like limited coverage we have. We were facing difficulties in detect concurrency bugs, and it was difficult to simulate the real workload scenarios. So the need we faced was to have a continuous randomized testing. So as a solution, we have developed this fuzzy tester, which is nothing but a Python-based testing tool. The key idea was simple, to continuously generate random database operations and validate the replication consistency and correctness, which should be automatic. The capabilities which this tool has, it generates the random schema changes, random DML changes. It has transaction blocks, concurrent workloads it can handle, and it's a continuous replication verification will be done at the same time. The goal was simple, to break the system before your actual users go and break the system. Yeah, so internally what he does, so he generates the thousands of operation sequences after every run. And this operation sequence includes schema operations. They have some data operations, other operations like create, drop, custom indexes. We have this copy from multiple sources and transaction blocks, which has both commits and rollbacks. Schema operations such as create and drop foreign tables. Since we made it specifically for our extension, which is like foreign data wrapper, we work only on foreign tables here. And dynamic options also it produces, which helped us find few bugs there. Alter table, drop, add column, drop column, alter column type, those operations are also supported. And as you can see, data operations are supported. Yeah, so next point is concurrency testing. As you know, concurrency testing is important part of any testing, so which exposes the race conditions and deadlocks. Along with that, it exposes the parallel concurrency issue in like multiple connection, multiple client scenarios. So for the same thing, we have configurable number of connections which you can provide to this tool, and on this each connection, it will run the random workload. Okay, this was about how you run the actual workloads on master. Now coming to how the replication validation happens under the hood. So first thing is you run the random workload in master. Then for the defined sequence, for defined minutes or some hours, whatever is configured, then stop the workload, wait for replica to catch up, one replica, two replica, and then run the consistency checks. If consistency checks are okay, consistency checks can be run like via checksums or something like that. If everything is okay, start the next cycle. If something fails, it will stop and report. Now after reporting, you can just go and check the logs. If you are in, if there is some crash and all, you can use a debug build of PG, and you can actually use address sanitizers and all, and you can debug the failure. And let's say you, after that also you are not able to find what is the root cause of the failure. You can reproduce the same issue by using a seed, because whenever this tool generates a random sequence, it first produces a seed value. In the consecutive run, you can actually provide the seed value, and you can reproduce the same sequence of the queries. So these are the few bugs. We discovered during this testing. As you can see, some data corruption in complex insert into select queries, some metadata inconsistency during writes, crash recovery failure. This was in wall replay, where we actually, it was related to some specific sequence of custom wall records, some memory errors in parallel execution, and deadlocks in concurrent DMS and alter. Okay, these are key takeaways. I'll just say random testing can reveal bugs that your traditional test, the deterministic test, can never hit. Yeah, thank you. If you have any questions, reach out to me.